Sisir Kumar Kapat, lecturer in Department of Computer Science and Engineering from UCP Engineering School, Barampur, Odisha. I am going to present the project namely Remote Health Monitoring System with Analytics Dashboard. This project is carried out to fulfill the terms of smartinternz gurucool program of IBM. The agenda to be discussed now is introduction to the project, then literature review, existing problem, proposed solution, block diagram, the hardware and software design, the experimental investigations, the flowcharts and result analysis, the advantages and disadvantages of the project, then application of the project, and conclusion, references. In introduction, I can say that the project addresses the current demand of wearable which could be developed further to function and meet the need of patients effectively. Suppose a person is wearing a watch and that watch can be used to regulate or to capture the health parameters, and it can generate the health report of the patient or the person, then it is better, far better. If I am using a mobile phone and that mobile phone is capable to capture the health parameters and generate the report, then it is far better. So in this case, we use the ICT, information and communication technology, efficiently and effectively. And another thing I can tell that some of the diseases are contagious, like suppose in COVID-19 situation, we don't want to go to the rush, we don't want to touch anyone who are vulnerable, who may be vulnerable to COVID-19. And another case is that the sensors which senses the user data, it decreases the possibility of human mistake, it ensures better care and treatment, it can reduce the medical expenses, it lessens the involved space of the room and improves overall performance. The purpose of this project is to use information and communication technology in healthcare. The persons are now very much busy and they don't want to go to the hospital in some cases because the persons may hesitate to tell the disease to somebody. In that cases, this project is very much helpful. This project may not replicate the healthcare system, but it ultimately supplements the existing healthcare system. The existing problems, I have already told some of the points, and other points are the persons are very much busy. They some of the times they don't want to go to the hospital because they have to stand in a queue. And another problem is the number of health professionals or number of doctors are limited. Suppose in a hospital, for example, some of the hospitals has 10 number of doctors, some of the hospitals are 15 number of doctors. This number is limited, and the doctors has to check a certain number of, the doctors can check a certain number of patients in a particular time interval. Let for example, a doctor can check the one patient in 5 minutes. So in an hour he can check a maximum of 12 number of patients. This number is fixed, and we cannot tell that a doctor can check 100 number of patients in 1 hour. Another thing is the patient who met with an accident, and some of the patients, like in delivery cases, the patients need immediate attention, the emergency attention. So in that case, this wearable or this project remote health monitoring system can help in a better manner, where the sensors can capture the values or health data, and it can send to the doctor, who can monitor the hourly or minutely data, minute by minute or hour by hour data, and the doctor can suggest. Nowadays the internet is used for some more complicated cases to be handled, and machine learning is also used in healthcare system. And if we use the internet of things devices, sensors, in that machine learning platform, then it could be very much better. It can give very much better result. The proposed solution is we can integrate some sensors with the handheld devices or some wearables, and the devices can sense the data, and it acts like transmitter, and it sends to the receiver side, where a machine learning platform is already deployed, and the machine learning platform will analyze the data and generate the health status report, and it will send back to the user. The block diagram of this system is divided into three parts. First part is the user interface, where the user has to enter his name, gender, and age. And the next part is IoT sensor interface, where the sensors will collect automatically the data. And third part is the machine learning model, which is deployed in the cloud. This is represented in the block diagram, where you can visualize that the upper block part is the part which generates the machine learning model. The machine learning model, to generate the machine learning model, first we have to need a data set, and the data set after collecting the data set, the data of the data set has to be pre-processed and refined, and after refinement the data is divided into two parts. First one is training part, second is testing part. The training part is used to train the model, and the testing part is to validate the model. After training and validation, the accuracy report will be generated. For example, some of the models has 95% accuracy, some of the models are 98% accuracy. The accuracy will be generated. After that, we save the model, and the model will be used to validate the data. In the lower part, you can visualize that the patient name, gender, and age is to be entered manually, and the health parameters from IoT devices will be collected automatically, and the data will be combinedly sent to the machine learning model, and after that the report will be generated accordingly. To design the hardware or software model, we use the IoT platform of IBM Watson, where we use the temperature sensor, blood pressure sensor, pulse sensor. The node-read interface is used to create the user interface, and machine learning model is used. Then cloud and database is used to store the data. The complete procedure of this system is described as: first we have to create one IBM academic initiative account. Then we create and launch the node-read instance, where we create the user interface, and IBM Watson IoT platform is used to simulate the sensors. The Watson Studio service is used to generate the machine learning model, and the Cloudent database is used to store the data. This is the interface where we log into the IBM Cloud, and where we can use the different resources of IBM, such as the Internet of Things platform service, machine learning service, Watson Studio service, Node-RED service. These are some of the services we can use from IBM. This interface shows the IBM Watson IoT platform service, where we have to sign in to enter into the IoT sensors, and after that we can create the devices, and we can create the different sensors. Here you can see that the temperature sensor, pulse sensor, and BP sensor, blood pressure sensor, are created or simulated, where the temperature value ranges from 0 to 41, pulse value 0 to 200, the systolic blood pressure 0 to 200, and diastolic blood pressure is 0 to 140. This lower limit and higher limit is decided as per the dataset. API keys are required for the different services in IBM Cloud, such as the database required one API key, the IoT devices require one API key. The Node-RED service is used to create the user interface, or the to show the sensors, the simulators. We can say that the Node-RED is used to control whole system, where the left part is used. You can see that the left part is used to design the user interfaces or the system, and the right side part is one example of the form which is created by using Node-RED, where the user can input his name, gender, and age. Here you can see that the leftmost node is IBM IoT node, which captures the data from different sensors like temperature sensor, BP sensor, and pulse sensor. The form node is used to capture the static data like name, gender, and age, and the data will be combined into a single message.payload object. Since this is two types of data are there. One is form data, which is static in nature, and IBM IoT data is dynamic in nature, and both the data has to be combined. We used the split node and then join node to join these two types of data into a single object. Then that data is sent to the prediction to machine learning platform, and appropriate prediction will be generated from that machine learning platform. This is the interface where we input our dataset, and we use the auto AI experiment service to generate the different pipelines, and out of all the pipeline we select one pipeline as our model. The dataset which is used here is having 5 parameters like age, temperature, BP systolic, BP diastolic, and the pulse. The machine learning model is created by using Auto AI experiment service, and the model is deployed in the cloud space. After deployed, this is the interface which is ready for testing. Here I used the age 32, temperature 35, systolic 100, diastolic 90 and pulse 70, and accordingly the result is generated as hypothermia. The machine learning model is out of the total pipelines generated. That means suppose there are 8 pipelines generated, then out of that 8 pipeline, only 1 pipeline will be considered as the model. And another thing is the data which is entered through the interface and which are generated through the IoT sensors, all the data with the prediction value will be stored in the database. I have used the name as health monitor on the database name, and all the data are stored as records. If I open one record, then you can see that the name, gender, age, temperature, systolic, diastolic, pulse and prediction, all the data are saved in the database. This saving method can be helpful in many of the cases, like some of the patients require historical data for the observation. In that case, it is very much helpful. In our experiment, there are two types of experiment. First one is cross validation, and second one is auto. There are two types of experiment. First one is cross validation, and second one is holdout. In cross validation, I represented the progress map for cross validation, where you can see that first it reads the data, then the data will be split into two parts. First one is training part and second is testing part. The training part is used to train the model, and the testing part is used to validate the model. Here two algorithms were used. First one is decision tree classifier and second is random forest classifier. The multi-class classification algorithm is used here. So 4 pipelines from decision tree classifier and 4 pipelines from random forest classifier are used. So first pipeline is without using any other services. The second pipelines are hyperparameter optimization. Third pipeline uses feature engineering, and fourth pipeline uses hyperparameter optimization. This is the representation of pipeline leaderboard, where you can see that the optimized accuracy is shown, where you can see that the pipeline number 3 has the accuracy of 95.9% and the build time is 36 seconds. Similarly, pipeline 4 is 95.9% and the build time is 13%. Similarly, all the pipelines are represented. What is accuracy then? The accuracy is the term which is the probability of correctly classifying the records. Here the formula for finding the accuracy is accuracy equal to true positive plus true negative divided by total. Then what is true positive? True positive is the number of correctly classifying instances. True negative is the number of incorrectly classifying incorrect instances. For example, suppose there are two values A and B. If A is classified as A, then that is called as true positive. If B is classified as B, then that is true negative. If A is classified as B or B is classified as A, then that will come under false positive and false negative. In multi-class classification, the true positive value is sum of the all true positive of all the pipelines. For example, the true positive is calculated as true positive of pipeline 1 plus true positive of pipeline 2 plus true positive of pipeline 3 up to true positive of pipeline number n. Similarly for true negative, false positive, everything. The precision of the classifier is the probability of records actually being in a class if they are classified to be in the class. The precision can be calculated as true positive divided by true positive plus false positive. Similarly, the recall of the classifier is the probability that a record is classified as being in a class if it is actually belong to that class. So recall equal to true positive divided by true positive plus false negative. And F measure is the harmonic mean of the precision and recall. Here F measure can also be called as F1 measure, which is calculated as 2 multiplied by recall multiplied by precision divided by recall plus precision. And these terms are very much essential to find out the accuracy of a model. Sometimes what happens, suppose there are two models M1 and M2. M1 is having less accuracy than M2, but in terms of precision, recall and F measure, M1 is having much stronger than M2. Then we can consider M1 as the model which is having less accuracy. The detailed accuracy of the pipelines are represented in the following figure, where the accuracy F1 macro, F1 micro, F1 weighted, and the log loss precision micro, precision macro, precision weighted, recall macro, recall micro, and recall weighted. These values are represented in this detailed accuracy. This accuracy is from cross-validation algorithm. This is the comparative analysis of different pipelines of cross-validation, where we can see that the pipeline number 3 outperforms all the other pipelines. This is also for cross-validation. And this one is the comparative analysis for holdout method, where the pipeline number 7 outperforms other pipelines. The holdout algorithm is a simplest type of cross-validation. What cross-validation is, suppose the dataset, in cross-validation, the dataset will be divided into n number of parts. One part is considered for testing and all other parts will be considered as considered for training. After training, the testing part will be considered for validation purpose, and this continues up to n number of times. Okay, so since after all the pipelines are completed, the final accuracy will be generated. Since holdout is the simple type of cross-validation, here we considered the cross-validation as our model. The flowchart is represented as: first, the user has to input his name, gender and age statically by using the form. The sensors will capture the temperature, blood pressure and pulse. Then the data will be sent to the machine learning platform. After data validation, if any report is generated, then the system will generate the error report. Similarly, if no error is there, then it will generate the health status report, which will be sent back to the user or the health professional. To analyze the report, first we need to know that there are two types of input. First one, form input, which is static. Another is sensor input, which is dynamic. And after that, the whole input will be sent to the machine learning platform where output will be generated. This one is the representation of form input, where the user has to input his name, gender and age. After clicking the submit, it will go to the cloud machine learning platform along with the sensor inputs. The sensor inputs are automatic. It will capture the user temperature, blood pressure and pulse. Then it will merge with the static data of the form, and that will be sent to the cloud. In the cloud, it will be validated and the prediction will be generated as per the machine learning platform, machine learning model. Here in the output section, you can see that the prediction is the combination of name, gender, age, temperature, systolic, diastolic, pulse and prediction. This data also will be stored in the cloud database. The whole system is a part of smartinternz gurucool program. This is the interface of smartinternz educator login page, and this is the dashboard page. Okay, now the advantages of this whole system is quick access, because no need to wait for anybody. We can capture our own data and send it to the cloud, so it need not to wait for any other person, so it is quick. Then it avoid contagious diseases, because we need not to go to any rush. Third is daily or hourly status of patient can be maintained for observation. This facility can be helpful to keep track of patients who are in critical condition like accident case or delivery case. Utilization of sensor decreases the possibility of human mistake. It ensures better care and treatment, reduces medical expenses by reducing the traveling frequency. It lessens the involved space of the room and improves overall performance, because the person is responsible to capture its own data and it will be saved in the cloud database. So the patient is 24 hours, the sensors can capture 24/7, and it can be observed, and the health report can be generated accordingly. The disadvantages is some of the diseases require privacy and confidentiality. If the database is hacked or exposure to the public, then it can violate the right to privacy of a person. Second thing, we cannot say this is the disadvantage, but we cannot replicate the healthcare system, but surely we can supplement the healthcare system by means of this project. The application of this project can be with the handheld devices like mobile phone, where the mobile phone can capture the different health parameters of the user and send to the cloud. Second application is some wearable like watches or bangles. Third is web-based monitoring like web pages. In conclusion, we can say that the healthcare system has to be improved with the evolution and revolution of new engineering and technology. Day by day, the information communication technology is improving, and as per that, the health care system has to be increased. In this system, the overall accuracy of this system is achieved to be 95.9%. In future, this figure should be improved. And another one, we have to keep track that this system should not violate any right to privacy of any person. These are the references which is used in the whole process of this project. Thank you.